Good morning. I am Dr. Anita DB, Associate Professor, CSE Data Science, ATME College of Engineering, Mysuru. I am going to demonstrate Program 4 of Machine Learning Lab. The statement of Program 4 is for a given set of training data examples stored in a CSV file, implement and demonstrate the FINDESS algorithm to output a description of set of all hypotheses consistent with the training examples. So before writing the program, first we need to understand the FINDESS algorithm and hypothesis concept. So this FINDESS algorithm is a simple machine learning algorithm used in concept learning. It finds the most specific hypothesis that is consistent with all positive examples in a given training data set. The algorithm assumes the first one. So the target must be represented in binary form, that is yes or no or true or false, etc. Then the second condition is the hypothesis space uses conjunctive attributes. Each attribute in a hypothesis must match exactly. The third condition is there is at least one positive example in a data set. In a given data set, so at least the target contains one positive examples. Then only we can apply this FINDESS algorithm. Now first import the necessary library, import pandas as PD, then read the data set. Data is equal to pd.read underscore CSV, that is a training underscore data dot CSV. So this file contains a simple data set, that is it contains only 5 samples with 4 features and 1 target. So the 4 features are experience, qualification, skill and age. The target is hired. So based on these 4 features, whether the candidate is hired or not. So as per the FINDESS algorithm assumption, the first assumption is the target concept is represented in a binary classification. So in this data set, the target is a binary classification, that is yes or no. Then the third condition of this FINDESS algorithm, there is at least one positive example in a data set. So now if you see this data set, there are 3 positive examples. So as per this FINDESS algorithm, the data set should contains at least one positive example. So now for this data set, we can easily apply the FINDESS algorithm. Now this is a function to apply that FINDESS algorithm for the given data set. So def FINDESS algorithm data, we need to pass the data set for this function. Then inside this function, the first step is extract features columns and target columns separately. So going to the data set, so it has 2 parts, that is feature and the target. So features are nothing but experience, qualification, skill and age. That is first 4 columns are features and the last column is the target. So the first step in this function, we need to separate the features, or we can also call it as attributes, and the target. So attributes is equal to data.ilog. We can use data.ilog function, that is data.ilog of colon comma colon -1 dot values. So it will extract all the columns except the last one, that is it will extract all the features and save it in the variable attributes. Then secondly, extract only the last column. Again we can use data.ilog function, ilog of colon comma -1 dot values. So it will extract only the last column, that is nothing but the target column. So after separating the attributes, that is a feature and the target, so the next step is initialize the hypothesis with the first positive example. Again, go back to the data set. So in this data set, so see that last column, that is hired. So there are 3 positive examples, yes, 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 and 2 no examples, that is negative samples. So for finders algorithm, we won't consider any negative samples. We'll consider only the positive samples. So in this data set, there are only 3 positive examples. So in this data set, first thing we have to identify the first positive example. So in this data set, the first sample itself is the positive examples. So now we need to write the code for identifying the first positive sample. So for this, we can use this part of the code. For I in range of len of target, if target of I double equals S, that is, we are identifying the positive examples. If the target is yes, first if we get first S, then in the hypothesis, save that corresponding feature samples. So attributes of I dot copy of, that is, make a copy of that particular sample to the hypothesis. Then break. So identify the first positive sample and assign that to hypothesis. Then the second step, update the hypothesis based on the other positive examples. Now compare this initial hypothesis with the all positive examples. So for I in range of len of target, if target of I double equals to yes. So as I already told, we won't consider negative samples for the finders algorithm. We need to consider only the positive samples. So if target of I double equals S, then for j in range of len of hypothesis, check the individual feature values of hypothesis with the particular attributes. If hypothesis of j not equal to attributes of ij, then replace the hypothesis of j by the question mark. So if we are going to this data set, now compare the features, that is experience, yes, yes. So there is a match. Then second, qualification, masters and bachelors, there is no match. So then replace that particular feature by question mark. Then Python, here there is a match. So no need to replace. Then 30-25, so there is a mismatch in the age. So replace that age feature by the question mark. So like this, we have to compare the initial hypothesis with all positive hypothesis, all positive samples, and if there is a match, no change, and if there is no match, then replace that corresponding value by the question mark. Then print I comma hypothesis. For individual sample, we can print the hypothesis, then return hypothesis. So this is the function for finders algorithm. Now call this function. Final hypothesis is equal to finders algorithm of data. Pass the data for this function and it will return the hypothesis. So print the most specific hypothesis, that is a final hypothesis. So this is the result. So the first initial hypothesis is yes, masters Python 30. Then after the comparison, we'll get like S question mark Python question mark, like S question mark Python question mark, then S all are question mark. So finally the most specific hypothesis is S question mark question mark question mark. So here the first column in the data set is the qualification. If we go to the data set, the first column is experience, the second column is qualification, third one is skill, and fourth one is age. And as per the final hypothesis, only the experience is yes, then all other three are question mark, then hired is equal to yes. The meaning of that final hypothesis is the hired yes is depending directly on the experience. If the candidate is having experience, then instead of checking like qualification, skill and age, they will get hired. So this is the meaning of this Finder's algorithm. So most specific hypothesis, yes, question mark, question mark, question mark. That is nothing but the outcome that is hired is depending on the experience. If experience is yes, then it is not depending on any other three features. So the candidate is hired directly if he or she is having a experience. Thank you.